How are you doing? This is Dr. Neil Paulvin, host of the Life Optimized podcast. We optimize life, health, business, and fitness. And I'm honored today to have Ryan Smith, the founder of TruDiagnostics, on with me. We're going to talk everything from epigenetics to biological age testing to the phenomenon now of the epigenetics and biological age leaderboard that you may have heard of with Brian Johnson. So I've known Ryan for a while now, and he always seems to be ahead of the curve in things that take off a year or two after he gets involved in them. So he's something you definitely want to check out on social media, or if you're an investor, one or the other. But I know he's a great guy, incredibly knowledgeable. So Ryan, like I said, I've met you multiple years ago at a conference, and you always seem to know what's coming up. And I know we had talked a while ago. I think you were going to go to med school, and then you kind of veered off that path. So how did you end up on the business side of wellness and health optimization, and give people an idea of how you got to where you are now with TruDiagnostic?
Yeah, certainly. It's been a long journey, but first and foremost, thanks so much for having me. Always excited to talk and catch up. But yeah, we have known each other a couple of years now. I think it's been probably like 6 years, I think, which is incredible to me. For those of you who might know me, they might know me from some of my previous work with the compounding pharmacy I created called Tailor Made Compounding. But before that, I essentially was a biochemistry undergrad student. So really interested in science from day one. I actually did go to medical school. I went to medical school at the University of Kentucky for basically 2.5 years. I passed my USMLE Step 1 boards. I was doing pretty well, but got to the clinical portion in my third year. And just hated it, quite frankly. I didn't want to do it any longer. So I made the very stupid financial decision at the time to quit, much to the chagrin of most people in my life. About 3 months later, decided to create a compounding pharmacy called Tailor Made Compounding. And that was a compounding pharmacy that was utilizing some of my background in biochemistry, particularly in peptide and protein biosynthesis, to create really unique and novel medications. So that company was started in February of 2016. And in 2019, we became the fourth fastest growing company in healthcare. So we grew sort of really rapidly, over 200 employees within 2.5 years. Really hitting a market niche in this integrative medicine space. But as we were doing a lot of new and unique products, the thing we were always wanting is validation data to show that they worked. We always knew the FDA might be knocking on our door eventually. And one of the tools that I was always looking for, particularly to use, was these methylation biological age tests, because you could predict outcomes better than any other molecular measurement. And so got really, really interested in them. And then ultimately decided to make it my full-time job. So we sold the pharmacy in March of 2020, to create TruDiagnostic, which started in July of 2020.
So right now, I'm preparing for talking to you today because, as I said, there's you specifically in biological age testing has gone from something that a lot of people in the optimization space is known to now. I think a majority of people are at least looking into is, are they real? Are they not real? Or how do you evaluate them? How do we use them? What context? So we're going to go through all that kind of as we go through. Okay. So let's start with at a broad scope, what does biological age mean to somebody who hasn't done all the research that you have?
Yeah, so I think that the concept of age just generally, for most people, is defined entirely as chronologic age, right? How long have they been alive since the moment they were born? And we know that's a huge risk factor, but we also know that there are people in their 70s who look like they're 50, and vice versa, people in their 50s who look like they're 70. And so that is really the more important process, not just because of aesthetics, right? But because aging, and particularly this biological aging process, is the number one risk for all chronic disease and death. And so biological age is essentially a way to measure that variance in aging that occurs with our age. And so age is defined as this progressive loss of function over time. And we just want to capture how well your body is performing and how well your body is I would say, decreasing that limitations that occur as we chronologically age.
And then, so the point first is, so biological age does not always correlate with your chronological age, with your calendar age. Exactly. And then, but when we go from there, there are probably now, you probably know better than me, I can think of 6 different variations of biological tests that are out there having different methodology. I mean, I'm not going to, I mean, if fair to name any other companies out there right now, but and they all have their pluses and minuses,
Yeah.
and they all have the data behind them right now. So you guys, as you mentioned, used the methylation method. I think you were had or have a relationship with Dr. Horvath and so on. So I don't know. I know we spoke a couple weeks ago,
Yeah.
and you updated your methodology. So explain how TruDiagnostic, the methylation method, and how you guys are trying to make this a
Yeah.
more exact science, no pun intended.
Yeah, certainly. So let me take a step back and just say that aging itself is incredibly complex, right? We don't want to make the same problem that the human genome made, right? Where they thought, hey, we're going to get the DNA sequence completely fleshed out and then we'll solve every problem in the world, only to leave people, wanting and wanting more from that project. In the case of aging is, even just 2 years ago when we started, there were 9 hallmarks of aging. Now there's over 14. And so as the science gets better, the resolution into what is defined as this aging process is only going to improve. So I think that the way to look at these biomarkers of aging is what captures or defines all of those different hallmarks of aging as best as possible. And this is something that's going to continue to improve over time. So we're always, I always use the example of cholesterol. Before we knew about particle size cholesterol, total cholesterol was a measure, and it was still one that was clinically valid and useful. And so these are always going to improve, and there are improvements made in every type of molecular diagnostic. So I always like to classify this into this multi-omic framework. And this is talking about genetics as one sort of omic, then epigenetics, then transcriptomics, then proteomics and metabolomics, and ultimately that phenotype, right? The phenomics of what ends up happening to the individual. And so all of these are being combined for biological age quantification. And this initially started, even in the 1920s with your biological age, which is your chronological age plus 1 year for every pack per day you smoked, right? So really crude measurements. But as these have evolved, we've gotten much, much more specific. And so I always want, before we go into the idea of what is the best biological age tool, I always want to talk about the tools we use to judge which one is the best biological age tool, right? Because at the end of the day, you don't just want to have a lot of competing statements saying we're the best or we're the best. You want to see it in the data. And so whenever we talk about what is the best test, there's really one metric, which is probably the most important, and that is hazard ratios to disease. So the idea is if we know that aging is the biggest risk factor, we want to be able to see that the people who are accelerated with our testing are more at risk for disease than those people who are decelerated for the testing. And when we compare it to other metrics, we want to see that one standard deviation in our test has more prediction capability of what happens to those patients than one standard deviation of other tests. And so that hazard ratio, the odds of a likelihood of a disease occurring, is one of the best tools that you can have. And that's what we'd really consider accuracy. How good is it at predicting an age-related outcome? The second one we talk about is precision. And so for that, we always talk about something called the interclass correlation value, or the ICC value. And this is basically an idea, if you take the exact same sample, and you test it multiple times, how correlated are all those results together? Ideally, if you test the exact same sample, you get the exact same measurement multiple different times. But that almost never happens, even with all your traditional clinical diagnostics. And so we want it to be as precise as possible, and we want it to be as predictive or accurate as possible. And so those are the tools we would usually go about measuring these things. So far, out of all of those different ways to measure, the one that definitively stands out as the most predictive and the most accurate at this moment tends to be the DNA methylation-based clocks. And so that's what we specialize in here. And these have undergone a big revolution since 2013. And really in 2013, when these started, these came out by Dr. Steve Horvath from UCLA, as you mentioned. And at first, they were trained to predict the chronological age of a patient. We call those first generation clocks. And so those clocks, as we talked about earlier, I think you mentioned that biological age doesn't always correlate with, your chronological age. And that was one of the big weaknesses with these first generation clocks, is they were trained to predict a chronological value, not a biological phenotype. And so really that was, I would say, the first generation that spurred on better generations. And in the second generation of these clocks, they started to be trained to predict biological phenotypes. So these are things, for instance, like grim age or pheno-age, really much, much better methylation-based clocks. And then next we have the third generation clock, which is the Dunedin pace clock. And that one is testing, again, phenotypes of aging, but it's testing them in the same patients across a longitudinal pathway. And whenever we compare all these clocks together, really the two that stick out the most are Grim-Age and the Dunedin pace. But the Dunedin pace algorithm, that rate of aging algorithm, definitively, I would say, is, in our opinion, the best. It's the most accurate, less than a 1% variation of testing the same sample. And it's trained on biological outcomes, and it responds to intervention we know beneficially affect the biology of aging, like caloric restriction. So that one is definitively, I would say, the best algorithm out of DNA methylation algorithm, and together probably the best biological age predictor.
Okay, so much to unpack there. Let me try to. We're going to try to now put like little subtitles on these so people who don't speak high-level science. So first, I want to go back to something you mentioned in terms of how do you assess the effectiveness of a clock, biological age clock. Is now you're saying how much within one standard deviation is going to predict disease, disease of aging.
Yeah.
Is that something that you can do? Is that something that's going to take years and years? That's one of the whole problems with aging science to begin with is, do we have to wait 30 years, 40 years to get enough people to evaluate to see how good something is, if it works or it doesn't work?
Yes. So the answer is no, you do not need that. And the reason being is because these data sets already exist. Particularly, they exist in these big biobank studies where people have taken samples from patients 60 years ago, sometimes as much as 80 years ago, and frozen the samples and saved them for future analysis. And so by looking at those samples, for instance, the Framingham Heart study, that's also how we judge the efficacy of an algorithm. How predictive is it? How is it associated to different disease outcomes? So first you have to train the predictor, and then you have to validate that it works. And those data sets, those big biobank data sets, are the way that we do that validation.
You keep using the term phenotype. So to people listening who don't have a science background, what does phenotype mean in an aging clock scenario here?
So the phenotype is just essentially the outcome that you would recognize. So whenever we talk about phenotype, it could be as simple as blue hair or blue eyes or blonde hair.
Now blue hair is common. Yeah, blue hair is
it is a phenotype. Not a biological one, but no, yeah. And so, I mean, it could be as simple as that, or we could get more complex phenotypes. So this could be things like high HDL cholesterol, or even just disease. Do they have COPD, or do they have, wrinkles on their skin? So it's the ultimate outcome that we're trying to define. And in the case of aging, most people can think about those outcomes that associate with age. So obviously you're thinking about gray hair, you're thinking about wrinkles, you're thinking about, loss of muscle mass, you're, all those things you typically think of or maybe fear when you get older. But maybe some of the things you don't associate necessarily with aging is also disease, right? So things like cancer, things like Alzheimer's disease, things like diabetes. There's a reason that people in their 30s are not getting cancer or disease at the same rates as people in their 60s. And one of those big reasons is the aging process itself. And so that's how we would define aging. Is it might be very complex, but all of those phenotypes which are associated with age.
Perfect. So let's take a complex process and start with the simple part. So right now, again, there's tons of different tests out there with you guys and most of the other ones as well. You're going to enter a bunch of data. I know when I've done it, it's about I think that looks like 7 pages of data now about your lifestyle. Do you smoke? What's your exercise?
Yeah.
Sorry,
I didn't mean to interrupt, but yeah. So for our testing, we ask a lot of those questions, but actually to generate the data, we only use one thing, which is the DNA methylation profiles we get from your DNA. And so that is the only information that we use. We ask the other questions to learn more about the associations to that aging process, so that we can, develop better predictors and get more precise. But really, whenever we get a sample, what we're asking for is a sample of blood. And from that, we're pulling out DNA from all those different immune cells, which are found in your blood. And then we're basically looking at 900,000 locations in your genome to get a relative percentage of methylation. So we're getting 900,000 numbers between 0 and 1. And we're plugging that into a mathematical algorithm, which is able to predict your biological aging process. But more than that, that data can be used and interpreted in a lot of different ways. We can predict how much you're drinking, how much you've ever smoked. We can predict how many heavy metals you've been exposed to. We can even predict when you're going to die. And so this is a biomarker which goes way beyond aging. It'll be used in every area of disease management going forward. But right now, it's really been pioneered in aging because it has such a high correlation to age-related outcomes.
So this is like a crystal ball into your health. So either they're going to be really good or scary and motivating all at the same time. So So like you said, it's a drop of blood, correct? It's not a blood draw.
Correct. Just a drop of blood, a couple drops of blood to be specific, but yes. Mm-hmm.
And then I'm Joe patient now. And then what am I getting when I get my results back from TruDiagnostic?
Yeah. So
using the clock.
Yeah. So we definitely, as I mentioned, believe that this data is a little bit, it can tell us a lot about a health of an individual, way beyond aging. But we have built really our platform and our initial research onto aging specific outcomes. So the first couple of things that we do are things that we call intrinsic and extrinsic age. These are your overall biological ages. So this will give you an age, right? If you're, 26, it might give you, a 30 range, or it might give you a 20 range in terms of your age. And with that, we also do the extrinsic age, which is essentially the immune age. And so here we tell you how your immune system is aging. And along with that, we're actually able to tell you even the relative percentage of each type of immune cell that you have. And this can be a really great biomarker, particularly when viewed through the eyes of a physician, because they can get this sort of a snapshot of how well your immune system is doing. And so the intrinsic and extrinsic age are really the first reports that we had. Very soon after that, we added that Dunedin pace marker, which we have already talked about as probably the best aging specific biomarker. And that tells you at this exact moment, how fast are you aging in a biological per year basis. So for instance, some people can age as little as 0.6 years for every chronological year. So the body is only aging 0.6 of the year and getting, the rest of the months free. And then some people, though, would be aging at 1.2 or 1.3 biological years for every year, meaning that they're aging faster than their chronological age. And that is definitively one of the best markers that we can look at. And then lastly, out of the age-specific biomarkers, we would also do telomere length. And telomere length is probably something that most listeners have probably heard about as an aging biomarker for a long, long time. But unfortunately, it's just really not that predictive of outcomes. It has some serious limitations there. But those are really I would say, really the four big age-related biomarkers that we're looking at. But we also have reporting to do things like, again, telling you how much you're drinking, telling you how likely you are to lose weight if you caloric restrict. We tell you, how many stem cell divisions you're undergoing per year. And our ability to interpret that data is only growing. The next reports that we'll have will be giving you an age for each different organ system in your body. So how is your kidneys versus your liver aging, or your heart or your brain? We'll also be able to report out things like physical function measurements, like VO2 max or grip strength or your walking speed. And that's actually one of the next reports that we'll do. And we'll also do inflammatory markers like C-reactive protein, IL-6, and TNF alpha. So all of those are coming out just within the next few months.
Okay, so you're going to be able to tell my VO2 max, which is a good predictor for longevity, just from my blood, from a couple of drops of blood?
Yeah, absolutely. And to do that, actually another great UCLA paper, it was called DNA Fit Age. And that's what they did. They took a lot of these, I would say, classical physiologic biomarkers of age, right? Which are, as we get older, our grip strength decreases. As we get older, our muscle mass decreases, our lung capacity and exercise capacity diminishes. And so they wanted to see if we could predict these with DNA methylation. And we can, so they're not nearly as accurate as some of the gold standard measurements, which are actually performing the VO2 max test yourself. But to do that, you actually have to, exercise, wear a mask over your face, and measure that lung functioning. And so it's not as good as that, but it is a good approximation whenever you can't do that.
So yeah, I've done the VO2 max. It's not fun, but it gives me really good information. That kind of like a lot of these aging tests are not the most fun, but you enjoy the information. So now you mentioned in terms of what was I going to say? So in terms of, when you're looking at these tests, what is, how much can I infer in terms of, if I'm going to know, okay, most of my biological age was low, or sorry, I'm phrasing differently. My biological age was above my chronological age. It's due to smoking. It's due to heavy metal exposure. Are you that specific yet? Or we just know, yes, you've done a lot of smoking. We don't know how much causation there is to your biological age.
Yeah. So right now the biological age measurements are just a measure. They're not an explainer. So they don't explain why we might be aging quickly. And they also don't explain if it's, I should say, we still don't know if these clocks are causal in the aging process. Are your DNA methylation abnormalities causing you to age, or is your aging process causing DNA methylation signals that we can read, right? We don't know that answer yet. But we do know that they're associated with outcomes still. So we do know that those people with younger measurements do better, and those people with older measurements do worse. And not just in age and disease, but all quality of life related metrics too, like how your skin looks, or your mental reasoning capabilities, your mental processing speeds, or your ability to stand or balance. All those activity data livings are also highly correlated. So we know this is a great predictor of outcomes, but we can't tell you what is affecting those predictors. I should say from the measurement itself on an N of 1 basis. But with that being said, we also now have multiple studies. There was just a recent review done by some of our collaborators at Yale, particularly Dr. Albert Higgins-Chan, who took over from Morgan Levine's lab when she left for Altos, but that have reviewed in meta-analyses of over 159 publications on these biological age clocks, and has been able to show their relative degree of impact on biological aging metrics. So we can tell you, for instance, that probably physical function, physical fitness has a lower degree to play in your aging process than things like sort of obesity or diabetes, for instance, or even socioeconomic status. So we can know from these big analyses how much of these things are correlated to different aging rates, and that can really set these baseline recommendations that we make. Right? Don't smoke, don't drink, make sure that you're not stressing too much, making sure you eat a proper diet that's and making sure your insulin is not you're not insulin resistant. Right? We know all these things from these big scale meta-analysis, but on an individual level, we can't just tell you what is specifically causing your aging process to age, and that's a big limitation, but one that is being corrected with things like these systems clocks, these ones that are giving aging rates for different organ systems. So you can sort of say, hey, my kidney health is not ideal, or my brain health is not ideal, and this is what's leading that aging process.
I get back to the organ clock in a second. It's come up in the news recently, but I want to kind of give people a little more information. In terms of, we use the term methylation and DNA methylation, and we see behind you the term epigenetics. So for people who are actually watching this on video, so explain to people what we're looking when you're talking about methylating the DNA. What's happened? I mean, there's why that happens and why you're specifically looking at that.
Yeah. So I think that it all starts with this idea that, our DNA is the baseline instructions of our body, right? But, if we took DNA from your skin or DNA from your heart, we would get the exact same sequence. But we also know that those cells are behaving very differently. Your skin cells are behaving like skin cells, and your heart cells are behaving like heart cells. And so whenever we start as pluripotent stem cells. These cells can become anything. But as they differentiate into the cell type they're supposed to become, that could be, the cells in your liver or in your pancreas or in your skin, they do so by turning on and turning off expression of your DNA. So these are not the hardware, but sort of the software of your DNA telling you what to actually turn on and turn off. And so there are a lot of ways it can do that, but the two most common ways are the on switches and the off switches, right? And that in particular, that off switch is DNA methylation. This is whenever we attach sort of a carbon group to your DNA. And by doing so, we prevent that gene from being activated. Essentially, the transcription machinery can attach to your DNA to make mRNA, which would then go to your ribosomes to create peptides and proteins. So we're sort of blocking the ability for your DNA to be turned on, and that's why it's an off switch. Conversely, the acetylation is that on switch, and that is a very promising biomarker for multiple different diagnostics, but it's a little bit harder to measure because we're talking about protein conformations. And so generally, most of the research, at least at this point, has been DNA methylation based.
There you go. And toxins and smoking and alcohol will lead to increased risks of methylation. Poor lifestyle choices can exacerbate or increase the amount of methylation there.
Well, yeah, and I want to make sure that that we're clear on something too, which is that methylation in and of itself is not a good or a bad thing. So in the case of tumor suppressor genes, right, these genes suppress tumors. You would not want those to be methylated. But on the other end, you have these oncogenes which can cause tumors, and you might want those to be methylated. So the methylation in and of itself is not good or bad. It's just sort of the pattern or the expression of the pattern, which is what we really want. And so every cell will have a perfect I should say a perfectly healthy epigenetic profile. But as we age, that can become disoriented. And that's really what we're trying to avoid, is any abnormal patterns which might lead to disease.
There you go. So now I want to go back. You mentioned about that you're coming down the pike soon with the organ clocks, which are going to give you a lot more specific information. And we talked offline before we started. that's become much more in the news here with the entrepreneur Brian Johnson and using your product, claiming that I think is 5.1 years. He cut his biological age down, and he's jumped up. I think he's the world. I think his term is he's the world record holder for your leaderboard, which we'll get into in a little bit. That you guys have made this actually motivating to be healthy, which is a good end goal here. And then he's also, and I'm not sure if he's using your data or somebody else's data. He's also mentioned that they've tested he has young kidneys, he's a young heart, and so on. I'm not sure if he's referring to your clocks, he's got or not. And so a couple questions again. I'll let you speak to your relationship with him in a second. Is people are either saying, "Wow, that's amazing! He cut his biological age by 5 years," and there's other people from profound scientists to the layperson who are saying, "Well, we know there's not a great relationship between biological age and true aging yet, and I could do 5 tests and I'm going to get 5 totally different answers." So how much can we take from what Brian Johnson is kind of talking about how important his dropping his biological age is for the reality for the person who also doesn't have $2 million, $3 million and a staff of 30 backing him up?
Yeah, so Brian is a very impressive individual. He's obviously made a lot of money in his career, but he's also super, I would say, committed to the cause of age reversal. And so his protocol goes way above and beyond what TruDiagnostic is doing. He is taking measurements that we wish everyone would take. He's doing things like full body MRI. He's doing liquid biopsy testing. He's been even doing pharmacokinetic testing for drugs to see what his body would have as an area under the curve for administration versus others. And so his resolution of diagnostics and imaging for his body is really unmatched by just about anyone that I know. He's getting more resolution into all of those things. And one of the small pieces that he's doing is also our testing, the DNA methylation based testing. And in our testing, he definitively has set a record for age reversal. He originally started, and he shared this publicly, so I can share it as well. But he originally started with a rate of aging that was above 1. And over the course of a year and a half, has actually decreased that to a rate of aging of 0.76, which is quite the reduction. And so he definitely is, I would say, committing to the process. His regimen and protocols are honestly like a full-time job. Not everyone in the world could do it, but I also don't think that everyone in the world needs to do it. He is definitely avant-garde, adopting a lot of things in early stages, but we know that things that cost $0 can still improve aging. For instance, things like caloric restriction, not eating as much, can have massive improvements on the biological aging process and health span. And so you don't need to spend $2 million. Brian is I think, taking this idea to its ultimate conclusion. What is the most I can do, and what is the most I can learn about myself as I measure this process? But he's not at all saying that that you can't do it with less.
No, it's perfectly said. That he's putting it out there what's capable, and I think he's pushing the limits, which is great. I think that needs to be done, but I think part of it, I think, has gotten lost with I want his marketing people, because every 5 seconds I'm getting a news blip about him. But that yes, you can, through caloric restriction, through good sleep, through maximizing your grip strength, all have longevity benefits him, and they're either very low cost or free. So I think that part needs to be kind of brought out there. But it's great that he's showing it diagnostically through your study, and he set a world record. And we'll get into that whole epigenetic leaderboard in a little bit. But again, which leads us into the next thing. So again, there are so many things out there now that have been either reported to be these new anti-aging wonder drugs, or things that both lifestyle-based and medication-based that have some good studies on them. I mean, we've gone from like DHA growth hormone, metformin. Now everybody's kind of in that every diabetic med at this point, the SGLT2s, and so right now, what do you see as the present in terms of the medicines and the lifestyle changes that have the most effect now on your biological age?
Yeah, so I would say that again, I want to answer this question from recognizing the limitations of testing, right? Because not everyone is doing what Brian is doing, which is testing every possible measurement ever, and getting that amount of data.
Yeah.
And so, with that being said, I think that as I mentioned earlier, I do believe the DNA methylation clocks right now are the best measurement of biological age, and we've learned a lot from them. And so, as a quick summary of some of the things we have learned, I also want to talk about the level of and thoroughness of the data in each of those categories. So. For instance, those epidemiological trials, they really are telling us things that we've known for a long time, right? They're not necessarily inventing the wheel again, which is things like, a healthy diet, making sure you're not, over consuming foods, things like stress reduction, making sure you get enough sleep, making sure you don't smoke or drink. Those are all things we've known for a long time, but it's actually a good thing that they're backed up in these trials with DNA methylation, because it shows that our assumptions are correct. And this testing is backing those assumptions, which have been developed by data for a long time. And then you get some of the first interventional trials. So in the case of DNA methylation, the first interventional trial, and the one that actually encouraged me to create this company, was Dr. Fay and Dr. Steve Horvath's trial on metformin, growth hormone, and DHEA. That was the TRIM trial, and showing the first ever, I would say, published interventional trial to show a baseline, treatment, and then an outcome. But there were some limitations with that trial, particularly, some of the early clocks were used, and then beyond that, it was only 7 or 9 patients, all of whom were men at a certain point in their life. And so there now, I would say, we're building data sets which are much bigger than 9 patients. We're big, our data set in general has over 20,000 patients now tested on our platform. And so our ability to learn more information and trends is getting a little bit better. We're not always doing controlled trials, but we are doing quite a bit of controlled trials. And so some of the things we've learned are pretty, stark. I would say that some of the things that everyone can do are, again, caloric restriction. And caloric restriction has been shown to work through inhibition of a key process called mTOR. And mTOR is the same, I would say, process that is inhibited with rapamycin. And so things that work on limiting mTOR definitively tend to have a positive impact on these biological age measurements. That is definitely one thing that we've seen. And this has even been proven in a 2-year caloric restriction trial, where they showed reductions in the Dunedin pace and Grimm age markers, as well as many of these other phenotypic biological markers. So I think that mTOR inhibition would be one of the first things on my list from an interventional perspective.
Now, this has also become a very hot button topic. So when you say caloric restriction to people now, what do you mean by caloric restriction? Are we talking 36-hour fast? Are we talking intermittent fasting, time restricted eating? In your mind, what do you mean by that?
Yeah, so I am only referencing a sort of an overall deficit of calories, traditionally on a daily basis. So the idea being that on every day you're eating, and particularly this study was done, 11% less calories than you're burning, essentially through your basal metabolic rate, and your intake of or activity levels. And with 11% caloric restriction over the course of 2 years, even in the course of 1 year, we see reductions in a lot of these biological age markers. And I would say that caloric restriction is probably one of the most well-validated interventions for lifespan and health span increase. I won't get into a lot of those time strategies. And the reason being is that, first off, we don't have the data, but secondarily, a lot of those strategies are not controlled for the total number of caloric intake, which I think is probably the more important marker. And so I can tell you that in our cohorts, and again, these have not been controlled like the calorie study was, but in our non-controlled cohorts, we do not see a benefit with time-restricted feeding.
There you go. And then are you guys doing any types of studies in terms of any of the other medications that are out there now, or right now it's more lifestyle based?
No, we're doing plenty of interventional studies on interventions. So we've completed a study now on senolytic medications like dasatinib and quercetin, and even the supplement fisetin, which had some interesting results. We've done studies on rapamycin. We've done studies on many different supplements, medications. We've done studies on even things like plasmapheresis or young plasma transfers. So we've done quite a bit of studies, interventional studies, on drugs and treatment medications. And they are all relatively small studies. So over the course of 3 months, usually anywhere from 25 to 45 patients, some now getting up to over 100 patients. So we're learning a lot from there, but not a lot that I can publicly speculate on until the data is completely published, which we should have several studies being published here very, very soon. And one I can speak on is sort of those senolytics, which are obviously very hot at the moment.
So to be continued. I think that's where aging is right now. I think everything is right now waiting the next year or two for a lot of these studies to come through to see exactly what's going to really give us the benefits and what's not.
Yeah.
So I think that's hopefully the near future. So what's the near future for TruDiagnostic here? I know you mentioned the organ clocks, and is that what do you see for the next 18 months in biological age testing? What's the next level?
So we knew whenever we first created the idea for this company that we wanted to create the best in class biological age test. And so for the last 2.5 years, we've been working on this project. It's been a very long project, a very expensive project, but one that is essentially almost complete. And in this study, we've created a sort of this multi-omic clock. And as I mentioned, aging is very, very complex. And I think that any single platform, whether it's epigenetics or glycans or proteomics or telomere length, anyone who says that one platform is the best platform ignores all the benefits that can be found in the other platforms. And so we really believe that a comprehensive omic strategy, getting as much information as possible from multiple individuals, is the best strategy. And this has been shown that composite biomarkers that use multiple sources of information are just better at predicting these outcomes. And so with some partners at Harvard, we've looked to create this multi-omic clock, which takes full genome sequencing, which does epigenetics, which does some transcriptomics or mRNA profiling, which does metabolomic profilings for over 3,500 metabolites, untargeted proteomics for over 7,000 proteins in the plasma, and then uses 75 clinical variables, things like your HDL cholesterol, your creatinine, for instance, and then takes that over people who've had multiple draw points from Harvard's Partners Biobank, and so we've created what we think is the most robust clock that's ever been created. To perform that clock, you would need to spend a lot of money on yourself, to do metabolomics, to do proteomics, and so we realized that that's not possible for most people. And so what we've tried to do is to train all of that back to methylation. So create a proteomic clock and train a methylation predictor of that proteomic clock, to do a metabolomic clock and do a methylation-based predictor of that metabolomic clock, and then ultimately train it all until time until death, as well as a sort of a biological age standard. And so we'll be coming out with that clock very, very soon, and it will be using all of the best tools and tricks in the space of methylation analysis. We hope to have it on our platform by March 1st, but we probably wouldn't expect a preprint to be released until probably sometime in mid-March or late March. But we're really, really excited about it. We think it'll be the best in-class biological age measurement for several years.
Always great. And I really appreciate that you acknowledge, right now, again, like you mentioned, there's different measuring sticks that are out there and they all add information. I know for me, for my patients, it's getting all that helps you kind of figure out where everybody is. And usually you can find a pattern one way or the other. The numbers are usually pretty good or pretty bad. You can find out hopefully where the red flags are as well. You mentioned like Dr. Morgan Levine has her with Altus has her stuff coming out, and everybody else, there's other ones out there as well that are very helpful. So I'm sure you get this question a lot. I'm 21 years old. Should I be already getting my biological age clock? If my family's health is pretty good, is it like when I'm 45? When should somebody go down the rabbit hole? Is it before things may happen so they can you can always make changes. But when should somebody really endeavor to be looking at doing a biological aging test?
Yeah. So, if money were no problem, right? I think that the answer would be as soon as possible. You should do it. Even in our Dunedin PACE cohort, we saw that the rate of aging at age 3 years of age was predictive of outcomes at age 45, how people were performing on those mental processing speeds, their physical function metrics. The rate of aging at age 3 was predictive of that at age 45. And so, there's never a time too early, I think, that you want to consider this aging process. Even as soon as you're born, you start the aging process and it can be optimized. However, with that being said, I think that, you probably are not having, I would say, too many departures from abnormal for the early early parts of your life. And I think that starting in your early mid 30s is a great place to start. The quicker that you can find out if you're on an abnormal trajectory, the quicker you can take an intervention. And so I think there's never a time too early. I think the science backs up that as well. But I think that if you want to be practical about it, I think the answer is, when are you ready to start making changes?
So you always go to kindergarten, your lunchbox in one hand, biological age test in the other, and you're ready to go. And then when do people, let's say I do my test at 35, should people be checking themselves every year, every 2 years, when they've initiated a 6-month change in their lifestyle, done caloric restriction, and what do you have any recommendations in terms of how frequently people should be doing them? Because I know I get asked that a lot.
Yeah, definitely. And this is a question which always changes, because the sensitivity of these tests are also changing. So, originally, if you were taking a test that had a 4-year margin of error, why would you take it more than once every 4 years, right? But now these tests are becoming so precise that we can find out a lot of information. And the information, I should say, the rationale for when do I test is not based on the test sensitivity, but it's based on the biological change sensitivity. And so we're still working that out. And while we're working out, I would not recommend a test more than every 6 months. With the Dunedin pace algorithm in particular, we are seeing significant changes picked up at right around 3 months. So you could do it as often as that. And that's actually why we came up with a lower price point test, just to do the Dunedin pace, because it is more predictive and can be done more frequently, which could be very, very helpful if you're thinking about starting a new intervention. You and I both might take metformin. My aging rate might go up, yours might go down. And this is a way that we can actually measure those inter-individual changes. But generally, I would say no more than once every 6 months. I would say that the majority of our practitioners are doing it with their patients once every 6 months or once every year.
Perfect. And can patients order the test directly through you? Do they have to go through a physician? How does that work?
Yeah, so they can order directly on our website, but I wouldn't recommend it. And the reason being is that we are not allowed to report on all the things that we can report on direct to consumer. Not to mention, I think that a clinical guidance and outlook on this is certainly a way to understand it better and more deeply. And so I think that, for instance, if you want your risk of diabetes, your inflammatory markers, some of those immune cell markers, then I would recommend going through a physician and getting much more resolution on these. And this is where the field of, I would say, of diagnostics is going. As I mentioned, even just over the last few years, methylation-based diagnostics have really taken off. Things like detecting cancer at stage 0 are all happening through DNA methylation. We can now even diagnose Alzheimer's or schizophrenia, things that were very hard diagnostically to do via blood markers in the case of Alzheimer's, or only clinical diagnosis in the case of schizophrenia, now have objective molecular biomarkers which can lead to a diagnosis. And so this information that you're generating on our platform will continue to be updated. We generally issue new reports about every 6 to 8 weeks. So even if you took a test with us 2.5 years ago, from the moment we started, now you'd be able to look at over essentially 12 different reports on our platform. So we're always updating, and I think that there's many other things you can find out, and you should definitely go through a physician.
I totally agree with that. I think it helps to focus and funnel where your best efforts would be, rather than trying to do 25 different things, unless you're Brian Johnson. But again, it's not feasible for everybody. So is your opinion, if you could do one thing to work on your biological age, that would be what?
I would say the one thing to do for biological aging would be to caloric restrict, at least at the moment. Eat less, if I were going to boil it down to one thing, but I can't also overlook all of the nutritional things, the physical function things, and honestly, stress reduction. That's also a very, very big one in my eyes.
That was easy said, and hopefully somewhat easy to do at this point. So where can everybody find TruDiagnostic? Is there layperson information on the site versus things that are more complicated? Where can they find information, and are there linked to doctors? How does that work with TruDiagnostic?
Yeah, certainly. So if you go onto our website, TruDiagnostic.com, you can certainly find out more information. We have things like ebooks to take you from, I would say, a novice or someone who's not very familiar with this information to being able to speak the language. And so we certainly have that information on there. We have a lot of, I would say, podcasts and video interviews with providers or researchers. We're doing a lot now, a researcher series with all the interventional trials we're doing. So if you're interested in interventions like ketamine or some of those other things, we talk about some of what we've found with those methylation signals of interventional trials there. We've talked to researchers who we've looked at methylation signatures for all for marijuana smoking or smoking just generally, or even alcohol abuse. So we talk about all the things that we're adding onto our platform on that forum. And so you can always look there, but if you have any specific questions, you can also always reach out to us at support@TruDiagnostic, or to me personally at Ryan@TruDiagnostic.com.
Hey, we'll get back to you. So he's the head of a company that will definitely get back, and he also knows one of the most informed people on this. So how much did you see with the alcohol on the biological age? Because that's that's something that's been in the press more and more, how bad alcohol can be for you.
Yeah, certainly. When we first started, the data actually suggested that, a couple of drinks of beer or wine per week were actually positive for you. And beyond that, or hard liquor was not. The new data suggests that's certainly not the case, that any amount of alcohol is not good. And I think that matches up more with our assumptions, but also shows how these clocks are better at capturing different types of interventions. So on average, if you have an alcohol use disorder, you're on average 2.2 years older than those people who are not, which doesn't sound like a lot, but it adds up over time.
That works. I can use that for my patients now and say that's motivating to them. So any final words on biological aging, what people need to know? And again, we already went to, and then just check out TruDiagnostic. It's very informative, a lot of good patient-centric information. You don't need to have a PhD in biochemistry to understand what the point is and what you need to do to help yourself out.
Yeah, couldn't agree more. And so definitely, if you're interested in this topic, I would just urge you to I think, help everyone understand the difference in what we talk about when we talk about aging. Aging is no longer, I think, viewed as just a chronological process or one that is purely vanity or aesthetics. This is a process which references how we live our lives and how healthy we can be. And I hope that if there's one takeaway from listening to this, it is to internalize that aging process to be more about health than it is about vanity.
There you go. And we're going to put all the links to TruDiagnostic and email to connect with them if you have any questions. So don't worry if you didn't get all the information that Ryan has on like a tip of his thumb there, and he can just reel up anytime he wants to. So thanks again, Ryan, the founder of TruDiagnostic, for coming on. And stay tuned for the next episodes of the Life Optimized podcast. Bye-bye.